It's audible, Avinash and team. Hello. Hello.
Hello.
Hello, Avinash.
Yes, sir. Yes, sir.
It's
You are
audible.
audible, sir.
Yeah.
Yes,
Okay.
yes, you are.
Yeah.
Uh, Amandeep, sir, can you hear us?
Yes, I can hear you.
Yeah.
Okay, okay, sir. Yes. Starting session.
Hello and good morning, everyone. I I hope you all are doing well. I Paramjot Singh welcome you all on behalf of Excelsior Education Society's KC College of Engineering and Management Studies and Research. I feel privileged to welcome you all here. I heartily welcome our Managing Director, Dr. Saikiran Khanna sir, in his absence. Now, I would like to welcome our Honorable Principal, Dr. Vilas Nitnavke. Uh, I would also like to welcome IETE-SF convener Dr. Babban Yurinde sir, IETE-SF faculty coordinator Professor Purnima Vadak ma'am. Last but not the least, our revered teachers without whom we students are not complete. They always support us and guide us in every unimaginable way. And of course, our starling students and the participants. I would like to thank all the participants from various colleges and institutes who have registered today for the webinar. Thank you so much for the overwhelming session response for the webinar on OptiSystem for communication and amplifier design simulation techniques. Now, without any further delay, let's begin the event. But prior to that, it's a matter of great pleasure and honor for me to invite someone who's among us for all his wisdom and his knowledge. Okay. Uh, Now, I would like to request uh, the HOD of the EXTC department, ESL head, ITSF convener, Dr. Bhaban Yurinde sir, to share a few words.
Thank you. Uh, First of all, good morning to one and all. All the faculty, those are joined on the in the online mode. That UG students, PG students, and our IETE-SF students of KCCMSR. It's a warm welcome to all of you under the banner of IETE-SF of this KCCMSR. We are organizing this today's event. That is the online mode national level webinar on OptiSystem for optical communication and amplifier design simulation techniques. Today's our the expert talk by the Amandeep Singh. Actually, this is he is the project manager, HR initial system, and he has the wide experience in the field of the optical communication, and he will give the about the how that you have to design the networks. Actually, why you are organize this event, this is also important because the OptiSystems systems, we have the powerful, this tool is available to use the photonic system design tool and also for the optical domain also. To plan and test and simulate the almost the every type of optical link in the transmission layer of a broad spectrum of optical networks, including LAN, ultra long haul, IoT, 5G, then LIDAR, sensor, and more of that will be there. And to create it to address the needs of research, scientific and photonic engineers, professors and students. So that will be the helpful for the optical networks to design for the designing purpose. Our students can be make the mini projects also, major projects also during their academics in the final year that we have the course also. This can be useful for the research work purpose also, and this is a advanced topic for the optical networks for the designing purpose in the research area also. In the 5G also, next coming is the 6G also. That will be the we can make the network, that is the backbone of the network, that can be made with the help of the optical network, and without that we cannot communicate properly. We will get the huge bandwidth with the help of this optical network. Therefore, we have the various applications that can be possible to create with the help of this optical fiber communication purpose, optical networking, to designing purpose, that coherent optical communication system. Then that is for with the help of the basic things we can implement PM PPSK, PM BPSK, PM QM. Then the latest one is also OFDM techniques, also orthogonal frequency division multiplexing. That we can make the networks fully. That is with the help of WDM, DWDM, and system for the optical amplifications, and we can use the UDFA also, Raman SOA, then PDFA amplifiers we can use. Then we can have the advanced formats of the communication also. The for communication purpose we can use for the digital communication, DPSK, then BPSK and MPM, MQM also. Then this is the for we have to generally we will get the experience with the analog, the latest one, that is the digital cable TV also, radio or fiber. Nowadays in Reliance also they have started the with the help of the air optical fiber, that we have the where we cannot put the fiber, that is impossible to put the fiber underground, or we can put that use the air optical fiber link, and we can communicate to the another end. Means that this will be the possible that our Narendra Modi ji also that having the target within that next within 20 years, that we have the fiber to the each and every villages. They have facilities. They have already started 5G also. They have launched, and the 6G that will comes in the in next coming that will be there for our. We are getting the advanced technology, and they definitely the every village school also connect with the help of the optical fiber, and we get the good communication. Students can not only learn through their teacher at their village, but that will be the connected to the world also internationally. That can be get the education to that particular student, medical facility, that can be given the guidance on the through the networking purpose. Various the application that can be possible with the help of this optical network. Therefore, this is a vast area and important area for the research also, for the students purpose also, to get the job in the the companies also. They get the opportunity with the help of this the today's the webinar. Therefore, I thanks once again to our team also for the ISF, IETE-SF. They have the organized today's event. Also, our ISF faculty members, she has taken the effort. That is Purnima Vadak. Always there, she is a backbone for this ISF team. The Avinash Rajak, and the all the Nikhil Chaudhary, Sumit, Rohit, Manas, and the Ria. They are the Paramjit Singh also, Harsh Patale also. They are the supporter to the this Avinash Rajak is the chairman for the our IETE-SF, and this is they are organizing various technical and non-technical events over throughout the academic year. Today's that we have the got the huge response actually. The 325 plus registration that will be and today also almost they are all registered. They have done the that they have joined through the online link also. We are connected to the YouTube also. Link also they have posted it, and other members also. Yeah, the under the this today's program, that students undergraduate students is joined 153. PG students also there. Then faculty also 150 plus faculty. Industry person also there. Research scholars also there 30 plus. These are the total strength of the 325 plus today that we have in the various participants that joined for this today's event, and almost 45 different cities that these participants are joined, and 10 plus states. That is the brief idea about the how that is our various the our members that joined for today's this activity, and already that Amandeep that will be give the more idea about this today's webinar. His last week that he has returned from the abroad is continuously on the abroad tour also. Therefore, I am thanks to him personally that he has accepted our invitation, and he has giving the accepted and giving the today's webinar on this optical networking topic. Therefore, thank you very much from my side. Over to you, Paranjit. Yes.
Yeah. Uh,
Thank you so much, sir, for your kind words. Now, uh, today's our today's eminent speaker is Mr. Amandeep Singh. Mr. Amandeep Singh comes with an 14 plus years of total experience in electronics and photonics
Paramjit.
design, automation.
Yeah. Abhishek Rasari joined. Abhishek sir, are you there? Yeah, continue, Paramjit. Continue.
Thank you, sir, for your kind words. Our today's eminent speaker is Mr. Amandeep Singh. Mr. Amandeep Singh comes with 14 plus years experience in electronics and photonics design automation domain. In his current role with MSHR Universal System Inclusive, in his current role with MSHR Universal System Inclusive, he is committed for his contribution to the technical aspects of photonic and electronics design and simulation with latest technologies and providing specialized services as a turnkey solution to nearly all IITs, NITs, Indian Defence Space and Research Organizations in India in the field of photonics up to component level. Sir, with his team, is engaged with various projects for design, simulation, and optimization of components, links, systems, and networks for the dynamically growing fields in photonics, nanotechnology, optoelectronics, optical networks, and other photonic applications for ISRO, SAC Ahmedabad, Lastec Delhi, LRD Bangalore, ADA Bangalore, etc. Prior to that, Sir has worked with MS Gigasoft India, New Delhi, in the Photonics division as an assistant manager, managing the application-oriented services related to electronics and photonics design automation for India and SAARC region. In his other past roles, Sir has worked with organizations like AMD Limited, New Delhi, as an application engineer for technical support on design and simulations. Sir also hold Cadence, OptiWave, RHC, RHCI, and RHSS certifications. Now, without any further ado, I would like to request Mr. Amandeep Singh to start the webinar. Over to you, sir.
Dear all, good morning, and thank you very much for this warm welcome. And in order to start with the new techniques, new concept, so maybe this is a new concept for the beginners, those who are just into the verge of learning of optical communication. And with the help of this platform, OptiSystem, we can share the knowledge how you can simulate a network before you go for its implementation. So let us start with the presentation.
Amandeep, please turn off your camera.
Oh, I forgot that. Just a minute. Yeah, I
Yeah, good.
hope. Yeah. So just a second. Let me share the screen. Yes, I hope this is visible to everyone. Okay, so first of all, OptiSystem for optical communication and amplifier design simulation techniques. So means optical communication is nothing just a combination of various components, and when you pass some information or data through speed of light, so it is nothing just a optical communication. So every data encrypted when we put it with the modulation and use a laser as a carrier, transmit it through a channel. A channel could be a fiber as well as a wireless communication, you can say, means free space optics. And at last, it is received or absorbed at a receiver end. So this whole process is optical communication. So it depends upon the various techniques you want to use, whether you want to communicate in a you can say a very short distance or to a long haul distances. Depending upon your application, we can uh, do some R&D on some communication components available inside the library of OptiSystem, and accordingly we can make a layout. So simulation is a necessity because before we actually go for the implementation, so we can determine what will be the cost behind all the components we will be utilizing for operation of optical communication applications. So this is the outline. I will be discussing these points with you. So overview of our company, then software product line, then the new components which are incorporated, then the most important free space optical communication, then using FSO, we will see how it is effective for underwater and for various atmospheric conditions, and at last the QKD concept, that is quantum key distribution. So I will just give a little overview of QKD because nowadays communication is fine, but securing the communication is also very important. So QKD will let us know how we can do these things. So we were like established in 1994 in Ottawa, and then we have created the tools for designing simulation and optimization of various components, including the links systems and the systems which help us to create the networks. We offers distinct competitive advantage through shortening the product line and then improving the product quality and then enhancing the productivity. So these are all interrelated with each other because whenever any corporate, whether it is a government or a private, they get gets a project, for example, if I get a project from for laying a optical fiber from Pune to Mumbai, so in that case I have to be very careful regarding all the enclosures which I require related to, you can see the permissions, the land like will be used for laying the optical fiber, and the type of optical fibers, and the components associated for transmission and reception, and its further distribution. So it's a long kind of, you can say, the system integration environment, and under that environment we can shorten the product time, improve the quality, and enhance the productivity. So simulation will help you to like decide which component is better for like completing your project synthesis, you can say. Then the main thing is we have the product line which completes all the tools, means which have all the components related to photonic designing and its simulation. So photonic designing is not limited to optical communication links only, but the components which you are using can also be designed using some other techniques. So let us see what products these are. So first of all, at a system level, we have OptiSystem and OptiSpice. So system level means you have a set of ready-made components with you. You change the parameters, and accordingly, you can connect it with each other and create a communication network environment, so that you can analyze its Q factor, its BER, its I, its signal to noise ratio, and a lot of other required parameters. So this will help you to set the various phenomena for selecting the levels of applications in communication network. And then OptiSpice. So OptiSpice is a tool which help you to design your own kind of optoelectronic device. For example, if you feel that in OptiSystem you don't have a desired component, and you have a application which involves optical as well as electrical circuit device, means optoelectronic circuit device, then you can construct the same inside OptiSpice. Basically this is a combination of two engines, optical and electrical. So once you are ready with the device inside OptiSpice, you can interface the same inside OptiSystem, and then you can see the characteristics and analyze the component, how it is behaving inside your communication environment. So this is, you can say, helpful in that way, like whatever you need in relation to optoelectronic devices, you can make it in OptiSpice and then interface it inside OptiSystem. Then we have component level designing. So this is a separate thing, because if you talk about modulators, if you talk about some kind of antenna as parameters, or if you talk about the gratings or your own customized kind of fibers which you may use inside OptiSystem, so these are the component level tools which help you to design your particular device application. For example, OptiBPM is used for designing your own kind of passive optical components. Means you must have heard couplers like optical couplers, splitters, power combiners, then Mach-Zehnder modulators or interferometers. So these kind of components can be designed inside BPM, and again the same designed component can be interfaced inside OptiSystem library. So this is another beauty of this GUI. Then we have OptiFDDT. So finite difference time domain based simulation design software. So it works on the basis of Maxwell equations. So the Maxwell equations are the algorithms on the basis of which this waveguide based design engine works for you. So in this platform, you can even analyze a minute nano cell of material, for example, gold, silver, or a combination of silver germania or silicon nitride, or there are a lot of combinations. Even you can make your own kind of materials, and then you can set the material for that kind of a substrate or a waveguide, and then you can analyze when the light passes through that particular material, how the material behaves and what all are the properties or the spectrums we are getting, right? Then we have opti mode. So for modal analysis of any kind of material or device, or you can say optical fiber, like nano scale optical fiber, or modal analysis of fiber based grating. So all kind of modal analysis can be depicted or can be characterized using this opti mode. Then we have OptiFiber. So OptiFiber is a tool which help you to generate your own kind of optical fiber. For example, in Pune, in Aurangabad, we have a company Sterlite. So they are using this OptiFiber and they are manufacturing optical fibers. So Sterlite is one of the company, those who are fabricating optical fibers. And another example you can say is HFCL and Aksh Optic Fibers. And there are a lot of optical fiber vendors in India as well, those who are utilizing these kind of simulation tools so that they can analyze before the actual manufacturing. Then we have optigrating. So optigrating is a tool which helps you to design fiber brag grating or grating based sensors. So in case you are interested to design your own kind of a sensor means which involves a lot of parameters like stress, strain, temperature, then light and its backscattering. So these kind of, like, these are just examples. So these kind of parameters, or you can say the devices, you can create through optigrating. So in India, one of the example is RRCat Indore. So this is a government organization, and it one of its department is utilizing optigrating for manufacturing grating based sensors or fiber brag gratings. So in India, that is only one of the fabrication facility available which is utilizing optigrating. So at last we have instrumentation level tool. So instrumentation level tool means, so this is a one of its own kind of a tool which help you to extract the values from a actual hardware you have in your lab. For example, you have a optical spectrum analyzer in your lab, and you have got some values inside that hardware, and you want to use these values in system level, means inside OptiSystem communication network platform. So in that case, you can utilize this Opti instrument to fetch the data using RS-232 or USB cable based connections. Then you have the facility to even characterize the data using Python and ASCII coding, and then the same data can be incorporated inside OptiSystem so that you can utilize this extracted data inside your simulation level platform. So it will also help you to understand how your actual fetched data from a hardware is behaving inside a simulation environment. So this is how it completes the whole set of photonic designing and simulation. So photonic designing and simulation comprising of system level, component level, and instrumentation level techniques. So I hope this overview related to the photonic designing and the products associated with this are like clear to you. And those who are new to this, they can log on to our website hrunisys.com or optiwave.com, and they can log in, register themselves, and they can download the 30 days evaluation. So these are the steps in case you want to download it. So this will like work in a full-fledged manner. So the only limitation is the time period, nothing more than that. So these are the design files. So once you are ready with the download, you can go around with these kind of files. Then we have component levels. So the component level means the components we have inside this, because this is very important to understand. Until or unless you know about the kind of components available to you, you cannot move forward. So first of all, light sources. So we have the light sources. Light sources are required at the transmitter portion. So continuous wave, LED, VSL, DFB, and there are a lot of light sources available. Then optical modulators, bit sequences, optical fibers, then electrical modulators. Then we have modulation formats as well, optical and electrical filters, then optoelectronic circuits. So the next level is signal processing, bit mapping detectors, optical amplifiers, electrical amplifiers, passive modules, multi-mode applications like fiber amplifiers, mode generators, optical channels, fiber, light fidelity, satellite, FSO, VLC, then visualizers. So visualizers are very important because uh, in case you are working in your lab on a optical bench where you have connected a lot of components and you want to see what is the actual characteristics of each and individual component, so you need to attach the components with some kind of visualizers like optical spectrum analyzers, your oscilloscopes, then your OTDRs, your like binary mode single signal generators, function generators. There are a lot of visualizers you may require in your lab, but in this case, we have a set of all the signals related visualizers like optical, electrical, binary, and M array. Accordingly, you can connect it as per your requirement and you can see what kind of signal and what is the intensity of the signal. Accordingly, you can analyze. So once you are ready with the installation, so you can see these kind of examples at right hand side, like advanced modulations, optical processing, dispersion compensation, microwave, multimode systems, optical amplifiers, sensor systems. So these all are the examples related to what actually available in the market and what actually have published in various renowned journals, right? So the main applications like advanced modulations need radio front haul, optical amplifiers, then microwave photonics, sensors including photonic crystal fibers, FBGs, then wireless communications including Li-Fi, visible light communication, satellite, underwater communication. Then we have special division multiplexing including multi-mode fiber, single mode, and multi-core fibers. So every concept or every application associated with optical communication, we have the components and you can exercise on the applications. So BTech final year students, or you can say the MTech students, PhD, postdoc, anybody those who are interested for these kind of applications, they can download this evaluation. They can talk to Dr. Baban, and then accordingly you can proceed further for the kind of research you are interested in. And at last, the QKD. So these are some of the components which we are integrated with, like OptiGrating, OptiBPM, OptiSpice, OptiInstrument, OptiMode. So like these modules are co-related, or you can say the interfaceable with OptiSystem. Also, it supports the third-party tools like MATLAB, Python. Then we have the external tools. You can say the Skylab, the ADS tool, the ORCAD, PSpice library files. So these are the third-party tools in case you want to utilize it inside your OptiSystem communication environment. You can use this. once you are clear that the function you have generated using third-party tool is like in a good operational package. So basically we have over more than 580 components, and the components are associated with these kind of signals like optical, electrical, binary, and ML. OptiSystem example library has over 1,000 examples demonstrating different applications. So these are the same examples I have elaborated to you. So now the new components, because OptiSystem 21 is released recently, and we have these new components. So these components are basically made on the request of our customers, or you can say the demand of the research tools, which requires these kind of particular research based modules like serial to parallel converter, digital comparator, line of sight underwater channel, then non light of sight underwater channel, non linear fiber Bragg grating, tilter fiber Bragg grating, then pulse polarization meter. So these are some of the new components incorporated. So these are the details. So I think first of all, let us move towards the software platform so that at least I can introduce you to the very basic of the tool. Let me share the screen. Okay, so this is OptiSystem 21.0. So once you click on OptiSystem, when you run this tool, so this screen will pop up, and at this section you can click on this new sheet. So a kind of a breadboard, or you can say a sheet where you can drag and drop your components, and then you can interconnect the components and design it. So under this default library, we have the set of components like visualizers, sensors, transmitters, WDM multiplexers, optical fibers library, amplifiers, multimode filters, PAS, passive receivers, and so on. Now, if I say I want to construct a optical link, or you can say the fiber optical link just for 10 kilometers. So in that case, I need some tools, some components. So first of all, a laser, which will act as a carrier because everything will be at a speed of light. Then bit sequences. Bit sequences means, see, if we talk about the audio, video, or some any kind of random data we want to send over a optical link. So first of all, that is encrypted, and at a receiver end it is decrypted. So in that case, we are using the data as a kind of random bits generated by the system, or you can also define it as your own. Define it as your own means, if I double click on this component, you can see here the bit sequences 0 1 0 1 1 0 1 1 1 0. So accordingly, you can add your own sequence also as per your requirement, and you can proceed. Whereas just for a demonstrating purpose, I'm utilizing pseudo random bit sequence generator. It will randomly generate the bits. So how it randomly generate the bits, it depends upon the global layout parameters. So if I double click at this section, I get a layout screen where I can change the bit rate of the whole simulation environment. So right now it is 10 exponential to 9 bit per second, means 10 Gbps. So the by default value of bitrate is 10 Gbps. I can use any bitrate. For example, if I just start with 2.5 Gbps, and within this range, the random bits will be generated. Further, these random bits will be required by a pulse generator. So the pulses in the form of NRZ, non-return to zero, will be generated. You can see here this input port of NRZ pulse generator requires a binary signal. So this binary signal is put into NRZ pulse generator, and this NRZ pulse generator will generate the electrical signal. Now we need a modulator. So we need to pack the things. So things are packed up means this is a kind of transmission, or you can say the data ready for the transmission, the modulated data. So this Mach-Zehnder modulator, if you are like interested in like communication and concepts of optical communication, kindly go through the data sheet of these components. So just right click on any component and go to the component help. Just a second. Let me open again. Right click on this, go to component help. So this is the data sheet for Mach-Zehnder modulator. Mach and Zehnder were the two scientists, those who have created the Mach-Zehnder modulator. And this simulates a Mach-Zehnder modulator using an analytical model. And in case you want to go through the technical background, you can go through this detail. It includes all the equations and functions related to the modulator. So similarly, for any kind of a component, like for this continuous wave laser source, so it generates a continuous wave optical signal. And this is the technical background for this laser source. So accordingly, you can see and read to like gain more information related to the optical components. Okay, now coming back to this. So transmission portion is over. Now we need a channel through which we can send this data. Uh, so related to the channel, any channel means, first of all, let us use a normal optical fiber. So if I double click on this optical fiber component, I can change the parameters. First of all, length is 10 kilometers. A reference wavelength is 1550 nm. So in case you want to keep on increasing the length, So accordingly, you have to play around with the attenuation and its dispersion parameters. So dispersion parameters are equally important because as the length changes, the attenuation and dispersion also gets changed depending upon the type or a kind of a fiber you are utilizing. So channel is fine. Now we need a receiver. So we have pin photodiode, APD, SPD, and so on. So first of all, I'm using this pin photodiode. So my 10 kilometers of optical communication link is over. This is done. So we need some visualizers now. So this is the most important visualizer. So why I have connected these three signals with this BER, because its first port requires the binary signal from a transmitter portion, means the binary data. Then the second port requires electrical signal again from the transmitter portion, and at last the electrical signal from the receiver side. So by getting all these three signals, it compares and give you some results. So let us simulate this and see if we are getting something or not. So this is a calculate button for the simulation. Calculation is finished. Q factor is 33, minimum bit error rate 1.1, and so on. So you can improve this. So this is the eye diagram. We have a huge eye height and eye space. This is fine, but you can improve this again. So for further process, you can play around with the parameters of the components. For example, the power. Here the power is 0 dBm, or you can say 1 milliwatt. So let us use 5 dBm at least. And optical amplifier as well, because some rule says keep on using amplifiers where you feel that you are not getting efficient results. And across this section, it's mandatory to use a filter. So under filters library, we have this electrical. We do have optical also, but here the pin photodiode, if you double click at the pin port, you can see it is an electrical signal. So as per the fundamental, we have to use the electrical filter here. And instead of this connection, we can join it to this. So now if I again simulate this section, let us see. So this is stuck up, just a second. There is a lag, just hold on. Okay, coming back to the session. So in case you want to like go for the simulations, it is mandatory to utilize high-end workstations, because due to multiple applications sometimes it gets stuck, so the simulation gets completed. So now you can see the maximum Q factor reached 129.02 and the minimum bit error rate is 0, and you can see that the eye height and ISI is minimum intersymbol interference. And further, these are some of the graphs which you may require for the presentation purpose or to analyze your system. Again, now I want to see how my Q factor is behaving, Q factor or like bit error rate is behaving when I use multiple distance locations, you can say, or multiple iterations. Starting from 10 kilometers up to 100 kilometers. So I want to analyze the system for 10 to 100 kilometers of range for optical communication link range. So these are the sweep iterations. That's it. So this is at 10th iteration. 10th iteration means at 100 kilometer. So this is our result for Q factor and BER. This is at 90, 80, 70, and so on up to 10. Also, you can make a graph here which can clarify the other values as well. For example, length versus maximum Q factor. So this is the graph for maximum Q factor with respect to the length. Further, you can also see the properties at data export toggle at 10 kilometers of a range. This is your Q factor at pi, and up to 100, this is this. So accordingly, you can see and analyze the graphs as per the parameters available in this report section. Then also length with respect to the average photo current at a receiver side. So this is the average photo current in milliampere with respect to the length of a optical communication link or a optical communication fiber. So accordingly, you can compare or create any kind of a chart. You can collect the data, you can export it to Excel file, and you can utilize the same in your thesis, in your project submissions, at any kind of any portion you want. Now coming back to this layout, so we have successfully created a link starting from 10 kilometers to 100 kilometers. And now in the similar way or in a similar kind of a component strategy, what you can do is, what if I say I need to make a inter-satellite communication link. So it's just a matter of a channel, because this channel, optical wireless channel, consists of all the parameters desired for inter-satellite communication or earth to satellite or satellite to earth communication. Let us see how, because data sheet is important for you to understand first of all. So this component models an optical wireless communication channel. It is a subsystem of two telescopes and the wireless communication channel between them. It is best suited for the modeling of satellite to satellite and earth to satellite links. So these are the parameters taken care of, like frequency, range, free space path loss, geometrical gain, transmitter aperture diameter, then receiver's aperture, transmitter telescope gain, and so on. Whatever related to this kind of a setup, you can find it inside a single box here. At last, the technical background and the references. So the references are from the renowned journals like Optical Society of America, SPIE, and Lightwave journals. So now again coming back to this OWC channel, if you see the range available is 200 kilometers. That is by default. You can increase the range as well. Then these are the by default values set for the transmitter and receiver aperture. Then its optics efficiency. Then for enhanced systems, you can use intensity scintillation. So let us stick to these values only. Now if I simulate this, so first of all, let us go to the by default iterations single. So Q factor is 44.59, minimum bit error rate is 0. So eye height is perfect. And again, in a similar way, if I choose to sweep this for the iterations, starting from 200 to 2000 kilometers, let us say, and also let us increase its power to some more values, 10 dBm. Let us guess this. The calculations are finished. So this is at 10th iteration, means at 2000 kilometers. Though it is not acceptable because Q factor is less than 6. So the publications may like cannot use this. Uh, but if we go to the first iteration, means at 200, then 400, then 600. Accordingly, you can see how the parameters are changing. Coming to this section, range with respect to maximum quality factor. So now you can see Q factor with respect to range, and these are the values at various ranges. So up to 1800 kilometer it is fine, manageable. So this is how you can do some R&D, or if you want to like go for some kind of applications related to free space optics. So you can explore it further. Also, in this case, if I again involve some other application base like wavelength division multiplexing, what if I want to communicate with some multiple satellites, or what if some multiple satellites want to have a inter-satellite communication with each other? So in that case, I need to introduce some kind of multiplexers and demultiplexers in order to achieve wavelength division multiplexing. So first of all, we have multiplexers here. So before we proceed, let me show you what actually this is. So just an overview. Basically, for example, uh, you have various kind of respective datas, like related to your broadband network, your communication line, your ATMs, your like you can say the private telephone channels, and so on. So whatever the kind of data will be at various wavelengths. So in order to pass the same data through a same single fiber, you require multiplexing and demultiplexing. So this is a kind of example. So from the central office, so you have individual fibers to a switch, and then muxing it, multiplexing it, and on a common pair of fibers, you are sending it to some location, let us say 200 kilometers, and at that 100, after 100 kilometers, so you need to demux it, means you need to separate that and make it the respective various channels so that you can read the respective data which have been sent through the central office or a location through the transmission. Okay, so coming back to this portion, so I am making separate transmitters at various wavelengths So again, it's my choice how I want to use it, means what kind of channel I want to use. So first of all, 193.1 is fine. Let us change this 193.2. I'm changing the frequency here. 193.3 and 4. Now coming back to this multiplexer. So at frequency 013, these are the values set up for WDM multiplexing. So you need to mention here the frequency of the channels. Then passing it through a channel. So here, first of all, so this is the range. Let us use it as it is, 200 kilometers. Amplifier is fine. It depends upon your need, if you want to use or not. And let us make it aside. Now I need a demux. Okay. So first of all, transmitting the data at various frequencies, then combining my 4 channels here with muxer, then passing it through a optical wireless channel or any channel you want, amplifying this, and at the receiver side the channels are separated with the demux. And if I simulate this, let us see if we get some result or not. So for the first channel, Q factor 106.13, minimum bit error rate 0. Second channel, again quality factor 100, minimum bit error rate 0. And this third one, third channel 102 is the Q factor, again bit error rate 0. And this is fourth 101 Q factor and PER 0. So for all the channels I am getting an excellent response. It means that uh, for multiple inter-satellite communication link, this WDM application concept is successful. So this is a kind of uh, fundamental, or you can play around these fundamentals. And if you want to achieve the desired research scenario, so you have to be careful regarding the parameters you are utilizing for constructing your application on this layout sheet. So I am careful regarding the frequency, the power, then its modulation, then its muxing, and inside this muxer I need to mention the channel frequencies I am using, then the channel I am using here, the optical wireless channel. So this is very important because these are the default values we are utilizing. But if you go through various kind of research papers, there may be a change in the transmitter aperture, there may be a change in the receiver aperture. So it depends upon application to application, and then there may not be a requirement of this optical amplifier here, but as such I am using it to like for the gain control operation. So that is the reason it is like the best view we are getting here in BER analyzer. Then again at last we are separating the channels and we are checking it out. So here instead of 4 you can use 8 channel, 16 channel, 32 channel, depending upon the kind of link you want to make. Also, apart from this OWC channel, if I again comes back to the fiber part, let us say inside your campus, not more than 2 kilometers you can say. So inside your campus, if I simulate this, calculating optical fiber, taking time, finished. First channel 403, second channel 219, 243, and fourth channel again 428. This may be the reason because 10 dBm is too much for this. So let us go with 2 dBm first of all. So this is just an R&D. You keep on doing the experiments, but it should be fundamentally right. So let us see if we get these results again. You can see that. So we can save the power. So these results are better than earlier. So accordingly you can, so now here if you want to see some other concepts like optical spectrum, when you are muxing it, and optical spectrum at individual channels when received. Apart from this, you can also consider this optical signal to noise ratio at any of these channels. Then if we talk about electrical visualizers, you can check RF spectrum. So let us simulate it again. So this is the optical spectrum for each wavelength, or for you can say for each channel I'm using, and this is the resolution at 0.01 nm, power versus wavelength. And For individual channel, so this is the sampled signal. Again, this is the sampled signal. And RF, so this is the RF value starting from 0 to 20G, up to 20G, you can say 20 gigahertz. So at this channel also the same values. So BTech and MTech students, so if I can make it in 5 minutes or in 10 minutes, you can like make a whole thesis related to such kind of applications, so that at a learning stage you can see how the things can be done beyond these kind of research and development related to optical communication and its applications. So this is WDM related uh, application. So here the length we are managing is with only 2 kilometers. What if I say, if I want to do it for a kind of a smart city concept, like in New Delhi, like in Bangalore, in Pune, in Mumbai? So the smart city concept that have been constructed long time ago, but if again you can analyze it, for example, for say for 60 kilometers. So here I may need to increase the power, but first of all, let us see at 60 kilometers if I have any manageable quality factor or BER. Yes, it's fine. Second channel, third, and fourth. Yes, this is perfect. So this is converted to smart city. Smart city means multiple data pass through a single mode fiber SMF, and then again distributed to various places. Okay, I forgot to mention this WDM analyzer. So this will give you signal power, noise power, signal noise ratio, signal to noise ratio, then noise power at 0.1 nm, then optical signal to noise ratio. So these are some of the important parameters. Like for example, if you have constructed this, your invigilator or your guide may ask you what is the optical signal to noise ratio at a receiver end of this channel. So this box, this WDM analyzer will help you to calculate optical signal to noise ratio. So this is 5.9 dB at 193.3 terahertz frequency. So this is how you can go ahead. And now the most important part is, what if okay, let us make a new sheet. Just a second. So this is the example for FSO system. simulations of FSO system operation in different atmospheric conditions. And this is the block diagram for this free space optical channel, and these are the attenuation values they have used. So now let us come back to this section. So we have this, first of all, FSO weather condition channel. So that is a new component or channel we have made. So this is a standalone component. So it can calculate the values for these kind of values, means dry weather consisting of clear haze and fog kind of environment. And it's further model type like Kim or Cruise model. So these are the models associated with their developers. Then in case you want to use this for precipitation type of environment like rain or snow, so precipitation type rain we have selected. You can select rain, snow, wet or dry, or any kind of your own defined uh, components. Then the precipitation rate you can mention millimeter per hour. So by default value is 1. Accordingly you can feed it out. So here visibility, if I say 1 kilometer, radius 1000 nm, wavelength 1550 nm, and I want to see it for clear haze or fog kind of environment, just for the analysis purpose. So these are the values like applicable scattering 2, attenuation dB per kilometer -10, attenuation coefficient 1 per kilometer is 2.3, and size parameter is 4.05. So accordingly, you can calculate the various factors related to FSO weather condition. Apart from this, we have this underwater channel. So similarly, this underwater channel will help you to decide the kind of attenuation you want to set for the environment, like pure sea, clear ocean, coastal ocean, harbor, or any other custom based water body. So first of all, let us start with this FSO channel. So this FSO channel will help you to determine, first of all, if I take example of this section, the same kind of concept we have designed earlier. It's simple. So to understand these kind of research, you need to go through the research papers, and you have to go through the block diagrams which consist of the components they are utilizing. Bit sequence generator, then pulse generator. You can use any pulse generator, NRZ, or even you can say experimentally RZ is better than NRZ, return to zero. But whereas uh, like RZ sometime does not give us much achievable values. So the reason is that is the reason we are using this NRZ. Even the comparison of NRZ and RZ is available on our website, so you can go through that. That example is published with the help of research papers, so you can go through that in your free time. So as per this paper, So very clear environment, 0.19 to 0.47. So let us start with this 0.19. First of all, so every time I'm using this optical amplifier, I know that this will not do any cost cutting here, but instead it is expensive. But accordingly, we can do some research and see how we can minimize the requirement of components accordingly. Now, if I use this BER, see, in case if the participants, if you have any questions, you can ask. No issues. So now related to the range, so if we comes into this section, they are using the distances of 500 meter, 100, 1000 meter, up to 2000 meters. So let us see, and they are using various power levels and wavelengths. So let us see if we can achieve the same. First of all, uh, frequency 850, power they were using, I think 10 milliwatt. So let us use 10 milliwatt. Range, let us start with 500 meters, and attenuation 0.19. Transmitter, let it be the transmitter and receiver settings be the same. Transmitter aperture diameter, beam divergence, transmitter loss, receiver aperture diameter and receiver loss. So now if I simulate this, perfect. So this is at 2.5 Gbps. Uh, just want to see what kind of bitrate they are looking for. So anyways, we can increase the bitrate to, okay, this is 10 Gbps. Fine, this is 10 Gbps. This is good. And even if we increase it to more than that, 20 Gbps, let us see if we get something. No, it's bad. It's not even average. 15 Gbps. It's fine. But BER is 7.9. It's fine. It's manageable. But at 10, it's good. Also, it was for 500. Let us sweep the values. 500, 1500, sorry, 500, 1000, 1500. 2000. So at these meters, we can see and compare. Let's open this report page. Range with respect to maximum Q factor. So these are the respective values at various ranges: 500, 1000, 1500, and 2000 meters. So yes, definitely we are achieving the results. So this is at fourth iteration, third, second, and first. Now, what if I change the factor to some light rain 6.27? So at light rain, so these are the Q factors. The Q factors changed, but it is again good. So you can see at 500, at 1000, at 1500, and at 2000 meters range. During light rain, this is the result I am achieving through this FSO channel. And similarly, what if I use it for moderate fog? Drastically drop down. So up to 1000 meters range, it was 4.9, and after that, your Q factor is 0. You lost the signal. And what if I use heavy fog? So these are just the mathematical values. Changes with every research paper. No result. Signal lost. 0. So accordingly, you can go for other kind of research or journal papers. Uh, Now, if we talk about some underwater kind of concepts, so you can again utilize uh, the various parameters. You can go through the attenuation factors, and as per various research papers, you can go for this. And let us delete this and use the another component. So here it is for clear ocean. Let us see if we get something. 0. So what if I use it for 350? Oh, sorry. Its range is up to 700 only. The 650, sorry. 650 you can use. Let us see if we get something. Again, no result. Anyways, we can use this component. So under these kind of links, just a second. So we have some another example related to this FSO. Just a second. Okay. So as per this paper, we can set the value for turbine harbor, if you can say, for the 650 nm 2.19, and the range is for, let it be, 100 meters. Scintillation I don't require, and it is for 650. Yes, fine, it's perfect. This is for 100 meters only. So what if I use it for 700 meters? Yes, it is also fine. See, in order to look into various kind of research journals, you can go through the research journals, and accordingly you can try to design the same using this platform. So accordingly, you can gain some experience. Okay, so I do hope the concepts of FSO related to atmospheric conditions as well as underwater conditions are clear. But before you proceed to such kind of experimentation, kindly refer as many as papers you can. And coming back to this component list, so we have updated the list to some new components. So like from which I have already used some of the components. So you can go through the resources as well, which talks about the release notes, the data sheets. So I have already explained you from where you can choose the data sheet for help button. You can go through the tutorials as well available inside the documentation portion. So this is the flowchart related to the free space optical communication. It is not restricted to the free space above ground only, but whereas you can use it for underwater applications as well. So a kind of concept related to the transmission and reception of the links for FSO. So for underwater channel, line of sight and non-line of sight both. So you can go through the examples. So even if you can go through this paper by Mr. Mehtab Singh and Dr. Ahmed. So underwater optical wireless channel transmission system based on OAM beams. Then QKD. So just a little overview related to this QKD, because QKD is a concept related to the computer science or quantum physics, you can say. So related to QKD, you can protect your sensitive information or data which you pass through a communication link. So this is being protected by the other kind of quantum computers or powerful computing resources. So the hackers, they always try to hack your data through cryptographic encryption or decryption based methods, whereas this QKD environment, quantum key distribution technique, help you to save your data. So this basically, in other words, this is the technology that uses quantum physics to create and distribute secure keys. It can be 0 or 1. So QKD is based on physical properties, and you can say it requires the special kind of hardware or equipments. So, so you can go through the paper. Let me show you the paper as well, because this is a kind of a concept which is like, just you can say, started few years back in India also. An efficient modeling and simulation of quantum key distribution protocols using OptiSystem. So just abstract. In this paper, we propose a modeling and simulation framework for quantum key distribution protocols using commercial photonic simulator OptiSystem. So this simulation framework emphasizes on experimental components of quantum key distribution. So we simulate BB84 protocol operation with several security attack scenario and noise immune key distribution in this work. We also investigate the efficiency of simulators inbuilt photonic components in terms of experimental configuration. So this simulation provides a study to analyze the impact of experimental photonic components in quantum key distribution process. So you can download this paper, you can go through this paper, And you can see this is designed using OptiSystem basic QKD setup, and this is the BB84 protocol mechanism, and this is operation with Eve's attack. So if one of the Eve, like they want to attack, and how the results of the achieved at the receiver side when Eve attacked the communication channel. So how the bits changed, and then evaluation of OptiSystem components. So you can go through this paper, and you can see how you can learn about this protocol and this QKD concept. So any question till now, anything you want to ask? Yeah, Dr. Babban and your team, any question if students have any query? So you are free to ask the queries.
Hello, hello, sir. Am I audible?
Yes, you are audible.
Sir, they have asked the question. Can you see the comment section?
Yeah, sure. Okay. Can we design the optical multi-stage network and simulate parallel route and analyze the performance of network using optical? Yes, definitely you can do that. Uh, Mr. Sumit Bhilare, yes, definitely the answer for your question is yes. So you can make it. So right now it will not be possible situation for me to like make the concept here, but definitely you can reach out to us and let me share my details with all of you so that you can reach to us. Just a second. So here at this section, I do hope you can see the screen. Is it possible to design an EDFA that can amplify at which wavelength is the most? Okay, yes, definitely. You can utilize EDFA available tool inside the library. So related to EDFA, you can find various kind of examples inside this OptiSystem. So you can find EDFA models and its analysis. You can go through and start with the basic concepts, and you can optimize the EDFA for its gain as well as noise, its pre-amplification, and as well as for its system margin as well. And related to the wavelength, you can optimize for various kind of wavelength. So whatever the wavelength best suits your environment for the application, you can select that. So 1350 is fine, it's not an issue. uh,
Sir, there is one more question left by Sai Anirudh before
okay, yeah.
Sumit Bilare.
Yes, yes, yes. Yes, yes, yes. So yes, long haul systems you can go through. Again, I will suggest you to go through the long haul system designing through OptiSystem. So you can easily get the research papers at ResearchGate website, or you can Google it, and definitely you can get a lot of long haul system designing ideas, and you can implement it. Even inside this OptiSystem sample library file, you can find the examples related to that. So first of all, you need to like download it and install it, and you can find the various ways and techniques to implement it. So in case anybody have any questions related to the applications you are working on, so we have given I have mentioned the details, contact number as well as the email ID. You can email me and we can discuss it further.
Thank you so much, sir, for the wonderful session. Now, let's forward to the last segment of the session, which is vote of thanks. A warm good afternoon to one and all present here. On behalf of the Department of Electronics and Telecommunication of Excelsior Education Society's KC College of Engineering and Management Studies and Research, with great respect and honor, we would like to take this opportunity to convey our sincere thanks to our enterprising and efficient Managing Director Dr. Saikarendra sir for his support. Special thank and deep gratitude to the HOD of Electronics and Telecommunication Department, head head of exam cell IETE-SF convener Dr. Babban sir for their encouragement and support. I thank all the gracing. Uh, I thank all the participants for gracing your crucial work and attending this webinar. Thank you so much for your cooperation. I also extend thanks to all the professors and other students for attending this webinar. We appreciate your support. Special thanks and deep gratitude. Special thanks and deep gratitude to our eminent speaker, Mr. Amandeep Singh. Thank you so much, sir, for taking out your time and sharing your valuables in front of us. I specifically thank the people who have been the backbone of the event. ITSF Chairman Avinash Rajak, Vice Chairman Janvi Arya, our technical arrangement team under the guidance of Manas Garde, content and anchoring head Harsh Patode, and all the ITSF core members for the organizing and making this event a great success. We would also like to inform you and request you all to take part in such amazing webinar activities we will be coming up with. Thank you for being with us. It was a great day having you all. Have a great day. Take care and stay safe. The feedback link has been shared in the YouTube live section, and all are requested to fill the form to receive the e-certificate. Thank you.
Thank you all.
Hello guys, the feedback form has been shared in the live comment section. You should fill the feedback form, otherwise you will not able to get the e-certificate or participation certificate. Okay, so guys, please fill the feedback. Thank you.